A warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we are going to discuss about the concept of paired t-test, when to conduct it, how to conduct it. I'll be answering you all the questions. If you like, you might go back to the playlist to watch in the other two types of t-test, that is independent samples t-test and one sample t-test. So, why do we do a paired t-test? A paired t-test is done to ascertain, to determine whether there is a difference in the means of the same group, a same sample, before the treatment and after a treatment is given to them. That means, in case we take an example of a class of students wherein an exam was conducted and the students scored marks out of 100. Now, the administration of the school decided to introduce video tutorial in the class and then conduct the exam once more. After the introduction of video tutorials in the class, say for a period of 1 month, the exam was reconducted. And again, the same set of students appeared for the test and they scored the marks. Now, if we want to study the effectiveness of these video tutorials which were launched in the class, whether they were a useful practice, a useful step in contributing to the marks of the student. So, we will be conducting a pair t-test wherein we have the readings of the marks of the students from 2 points in time. One before the launch of video tutorials in the class and one after the launch of video tutorials in the class. So I'll be showing to you how to conduct this peer t-test along with the assumptions of this test in SPSS. So let us start. A paired sample t-test tells about the mean differences between the pair of observations from the same sample. It is used to determine if there is a statistically significant difference between the pre-test score and the post-test score produced by using the same instrument. Assumptions are differences between the dependent variables that are continuous in nature to be normally distributed. How do we ascertain the differences between the dependent variables? We first need to take out the differences as a variable in our data sheet. For that purpose, we go to transform, compute, target variable. We name it difference and then we give the numeric expression as pre-test minus post-test scores. So after transforming the variable, that is getting the difference between the pre-test and the post-test scores, the next step is to analyze the normality and check for the outliers in this new variable, which is the difference score between the pre-test and the post-test. So for that purpose, we'll go to analyze, descriptive statistics, explore, move the difference score to the dependent list, go to statistics, tick descriptives and outliers, go to plots, uncheck stem and leaf, and check histogram and normality plots with tests. No change in the options and exclude cases list-wise. Click OK. I'll be showing you how to conduct these steps in SPSS in a while. Next, we check for the skewness and kurtosis values. Skewness, the absolute skewness value, as I told you in my previous video also, can be determined. The normality can be determined using different methods. We will be using a method wherein we'll check the skewness, whether it lies between -2 to +2, and kurtosis absolute value lies between -3 to +3 to signify that our data has normality assumption fulfilled. Then differences between the dependent variable should not have any outliers. We'll be checking it through the box plot. No points with asterisk mark should lie above and below the whiskers. Now, the problem is to check whether there is a difference in the performance of the students after introducing the video tutorials in the class. Null hypothesis for this test would be there is no difference, and alternate would be there is a difference. So we have to prove it statistically whether there is a difference or not. How to do it? Let us check it out in SPSS. We'll go to analyze, compare means, paired sample t-test. We'll select the variable 1, that is the pre-test score, and variable 2, that is the post-test score. In the options, we click on 95% confidence interval and exclude cases analysis by analysis. Click OK. Now closely observe the paired sample statistics. Compare the mean for pre-test and post-test scores. Check the p-value. If it is below 0.05, then reject the null hypothesis, which was there is no statistical difference between the pre-test and the post-test scores. Here we are in our SPSS and we have 50 cases with us. You see case ID 50, and we have the scores of 50 students, that is pre-tutorial, before the introduction of video tutorials in the class, after the introduction of video tutorials in the class. Both of them are on a continuous measurement scale and they are out of 100. So these are the pre-tutorial scores and these are the post-tutorial scores. The first step is to know the difference between the pre-tutorial and the post-tutorial scores. For that purpose, we'll go to transform, compute variable, target variable, we name it difference, and here in the numeric expression, looking here carefully, we want to determine and we assume that there is a significant progress in the students' marks after introduction of the video tutorials. So for that reason, I'll move the post-tutorial marks to the numerical expression and then I click on this subtract sign and then move the pre-tutorial marks, because if this difference comes as positive, that means the video tutorial has helped to improve the marks of the students. So the numeric expression in this case would be post-tutorial marks minus the pre-tutorial marks. I click on OK. So that will create a new variable in my data sheet, which is known as difference. And this is the difference in the marks of the students observed after introducing the video tutorials in the class. So as you can see, 57 minus pre-tutorial score, that is 61, it is -4. So now I want to check the normality and check whether there are any outliers in this variable, which is difference. For that purpose, I'll go to analyze, descriptive statistics, explore, and move this difference to the dependent list. In statistics, I just click on descriptives and the confidence interval for the mean should be 95%. Click continue, go to plots, uncheck stem and leaf, and click on histogram and normality plots with test. Now I press continue and again OK. So that will give me the descriptive statistics, the case processing summary. You can see here the valid number of cases is 50. There are no missing cases. The mean is 5.02. This is the mean for the difference variable. I'm more interested in knowing the skewness and kurtosis. Skewness is 0.344, which is well within the limits of -2 to +2. Absolute kurtosis is -0.178, which is well within the limits of -2 to +2 again. If I go with the test of normality, KS test, which is prescribed in case the sample size is more than 50, and Shapiro-Wilk when the sample size is less than 50. I see here both the KS test and the Shapiro-Wilk test has a p-value which is insignificant as it is more than 0.05. It is 0.200 in KS test and Shapiro-Wilk test is 0.328, which is again more than 0.05. So it is insignificant. That means I cannot reject the null hypothesis. The null hypothesis in the case of test of normality is that the distribution is normal. So I do not reject it as the p-value is insignificant. So I can say that my data is normally distributed. The difference between the post-tutorial and the pre-tutorial marks, I checked the normality for that and found out that it exhibits normal distribution. I can assess the same through the histogram, which seems like a bell-shaped curve. You see over here, it seems like a bell-shaped curve. If I want to see the QQ plot, I can see that most of the points are lying on this diagonal line, the slant line. And if I want to check the outliers, I go to the box plot and check whether there are any points lying above the upper whisker or below the bottom whisker. Those can be said to be the outliers. So in this case, we don't have any outliers. So I've checked the assumption of normality and I've checked for the outliers in my data. It's all okay. And now I can go with the testing of paired samples t-test. How to do that? Again, I go back to the data sheet. I go to analyze, compare means, and here you see paired samples t-test. In variable 1, I enter the pre-tutorial marks. In variable 2, I enter the post-tutorial marks. So variable 1 and variable 2. In options, I do not need to check anything. Confidence interval percentage again has to be 95% because I'm doing the testing at 95% confidence interval. I click on continue and press OK. So now I have the results. You see here the mean in case of pre-tutorial, pre-video tutorial marks is 64.78 out of 100. In case of post-tutorial marks, it is 69.80. So there seems to be a difference of almost 5 points between them. But whether this difference is significant or not, we are going to check that, and that will help us determine whether there was an effect of introducing the video tutorials in the class upon the students' performance. So I check the next table, which is paired samples correlation. So there is a correlation of 0.793 between the pre-tutorial and post-tutorial marks, which is a significant correlation as the p-value is below 0.05. Then I check the paired samples test table. Herein I have the mean, which is minus 5.02. That is the mean difference between the pre-tutorial marks and the post-tutorial marks. The standard deviation 5.07 and the 95% confidence interval if I see the lower limit and the upper limit. So I see that there's no zero coming in between. So that means it is significant. As I can see from the p-value as well, the p-value is below 0.05. It's 0.000 in this case. That means there is a significant effect of introducing the video tutorial upon the marks scored by the students in the class. So, there is an effect, and that is how we conclude that video tutorials were helpful in enhancing the score of the students. As we see here, the mean has improved significantly. So I hope the video was quite interesting and knowledgeable for you, and you will definitely share it with your friends and faculty colleagues. Thanks for watching and keep watching for more.